So we're about to be jumping back into quadratics. We took a little leap away from quadratic equations to deal with the complex numbers because we need to be able to find quadratic, irrational, complex numbers, solutions for quadratics. So now we're going to be going back into how to solve these quadratic equations, these square equations that make parabolas when we graph them, which we haven't really gotten into the graphing yet. But and today what we're talking about is the method of completing the square. We've been doing factoring methods all along, but factoring methods don't always work for us, right? Because we can get into some really complex factoring. Completing the square and the quadratic formula are two methods that will always work, no matter what quadratic that you have. So remember that we've been dealing with things in terms of ax squared plus bx plus c, right? And these signs can change in here. It's perfectly fine. But when we're talking about completing the square, what we're using is the idea that we have these perfect square trinomials. And our Algebra 2 doesn't really jump into this very well for us. But what a perfect square trinomial basically is saying that when we have a perfect square here, and well, let's see, I'm trying to think of the best way to determine. I think it'll be better if I use an actual problem instead of a. So say I have x squared plus 14x plus 49, and say it equals 4, right? This right here is considered a perfect square trinomial. And it's because we have a perfect square here in this position, and we have a perfect square here in this position, right? This is x times x. This is 7 times 7. This is like saying x squared. It already says that. But this is the same as saying 7 squared, right? And this, or this term right here, equals 2 times a times b, right? Because 2 times x times 7. And so when I have anything in this fashion, these perfect square trinomials, what it allows me to do is it allows me, if this is positive, it allows me to write this as x plus 7 squared equals 4, right? And from that, we can find our solutions, right? Because we know that whatever these little factors break down to, that's like saying x plus 7 times x plus 7, right? Which means I can set each of these up to that 4. I could go x plus 7 equals 4 and then just solve it. And I have two of the same solution. And so the idea of completing the square, I just have to finish solving it. I can't stop myself. I wind up with x equals -3, right? And it's just a repeated solution. It's a perfect square. We have two of them, so it's the same solution repeated. And that solution is x equals -3, because that's what we're solving for. We're trying to figure out what x is, right? Well, let's look at another example. If I have x squared, minus 6x minus 6x plus 9. If I wanted to write this in terms of a perfect square trinomial and the factors, I would know that that factor is going to be the square root of this minus the square root of this, right? And that's how we break those down. I'm trying to think of other ones off the top of my head, but I can't. So the idea of this is creating these perfect squares so that we can solve any quadratic. And the way we do that is we use steps. I like steps whenever I can. So completing the square, steps. Right, number one, we want to rewrite whatever we have as an ax squared plus bx equals c. Basically, it's saying we're going to move our c over. Now, don't worry about the steps till we get to them. I'm going to show you how to do all of this. Then we're going to divide both sides by a if a is not equal to 1. Divide both sides by a if a is not equal to 1, if necessary, right? We'll just put if necessary. Number 3, we're going to complete the square by taking half of b, half of our b term, and squaring it. Then add it to both sides of the equation, whatever term we come up with. Sorry, my handwriting's getting bad as I move down the screen. Not that it was all that perfect before. Now we're going to factor it because we created a perfect square trinomial. And then we're going to take the square root of both sides. You should get 2 solutions, one positive, one negative, and then you're just going to solve both equations. So let's see what that looks like in practice. Equations. So a lot of steps, write them down. Stop the video, take the notes. You should know how to do this. Because when you get quizzed on this, I'm probably going to only, for this section, this whole quadratics thing we've been doing is you'll have to solve by completing the square and you'll have to solve using the quadratic equation. So you need to get these 2 methods down. We will go over this in class next week as well. So let's look at some examples of how to do this. If I have x squared minus 18x plus 56 equals 0. And I am told to solve by completing the square. And you will be because that's what this assignment is. The first thing that we're going to do is if you go back and look at your first step, it says rewrite as ax squared plus, I don't know where it went, ax squared plus bx equals c, which just means that I need to move this 56 over, right? I just need to subtract 56 from both sides so that I am left with x squared minus 18x. I'm going to leave a little gap, equals negative 56. The reason I'm leaving the gap is because I'm going to put something in there. I'm going to add something to it. So we're going to look at here. The next step it says to do is divide both sides by a if necessary, but our a term is just 1. So we don't need to actually do that in this case, right? Because if I divided everything by 1, it would stay exactly the same. And the next says complete the square by taking half of b. Well, b is negative 18. So we're going to divide that by 2. And then it says we're going to square it, right? So if I look at that, negative 18 divided by 2 is just negative 9. And when I square that, I get positive 81. And it says then we're going to take whatever we get and we're going to add it to both sides, right? This is going to create this perfect square trinomial. Notice x squared is a perfect square. It's x times x. 81 is a perfect square. It's 9 times 9. If I multiply 9 times 1, I get 9, and I double that, so it works well. So this is just going to become, for us, it's going to become x minus 9 squared, and it's going to equal 25, right? And we can easily solve that now by taking the square root of both sides, right? I can go, okay, well, I have a square, perfect square here, and perfect square here. Just like if I had x squared, I'd take the square root. Here, I'm going to take the square root as well. And I'm going to be left with x minus 9 equals plus or minus 5, right? The square root of 25 is just 5. And now I can solve. And I'm getting two solutions, right? I'm getting x minus 9 equals positive 5, and I'm getting x minus 9 equals negative 5. I can separate these out, right? X minus 9 equals 5, and x minus 9 equals negative 5. And we're going to get our two solutions just by solving for x. So we're going to go plus 9 plus 9. And you go x equals 14. And here we're going to go plus 9 and get x equals 4. These are our two solutions for x. What they determine is where on a graph our parabola is going to cross the x-axis, right? We haven't gotten into the vertex or anything of that yet when we're graphing it, and we're going to get to that after the quadratic formula. But what it's saying is that I'm going to have a point here at x equals 4 and another point somewhere down here at x equals 14. And there's going to be a parabola, right? That U shape is a parabola where it goes through. Let's look at another example, one where we actually have to divide out our a term. So if I have 2x squared minus 16x equals negative 30, I don't have to move the term over now, right? There's not one on this side. But so I'm going to move on to the next step, which is divide by our a term. If our a term isn't 1, we have to do the math on that. We have to divide every piece by 2 so that we're left with x squared minus 8x equals negative 15. And now we're going to go back and start the next step of the work of completing the square. We're going to take half of our b term. Our b term is always what's in front of just x, right? So we're going to take negative 8 and divide it by 2, half of our b term. And then we're going to square it, right? That's the same as negative 8 divided by 2 is just negative 4. And when we square that, we get positive 16. So what we're going to do is rewrite this as x squared minus 8x plus 16 equals negative 15 plus 16. We're going to add that 16 in to both sides of the equal sign. And here we can write now our perfect square. We've got x, because the square root of x squared is x, minus the square root of 16, which is 4, equals, well, minus 15 plus 16 is just 1. And now we can solve this taking the square root of both sides. So we are left with x minus 4, right, whatever's inside what's being squared, equals plus or minus 1. And now we can solve them each individually. We can go x minus 4 equals 1 and x minus 4 equals negative 1. And we can figure out what each x solution is. And in this case, we're just going to add 4 to both sides, and we will get x equals 5 is one of our solutions. Here we're going to add 4 to both sides, and we're going to get x equals 3 as our other solution, right? There's always going to be 2 x solutions, and it's saying that if I graphed it, right, here at 3, I would have a point on the x-axis, and here at 5, I would have a point on the x-axis. This is a positive parabola, and so we could just draw. I mean, there's more specifics. You'd have to be able to find a vertex, but we're not there yet. But it gives you an idea of what those solutions indicate. Trying to see if I want to do any more problems with you. I think that that's fairly sufficient. Actually, I'm going to do one more example with you, just because I know you have a homework problem that deals with it in terms of if I have 4x squared plus 76 equals 16x, we need to get this in the proper order. We need to move this x term over here and then move this constant on this side. So what that means is that I need to manipulate this before I start. And I'm going to start by subtracting 76 from both sides, which would give me 4x squared equals 16x minus 76. And then I'm just going to subtract 16x from both sides to move that over. So minus 16x minus 16x. And then I can rewrite this as 4x squared minus 16x equals negative 76. And then we can just solve it like we were solving the others, right? We've got our constant moved over. Our next step would be to divide out this 4 that's in our A position. So we divide by 4 here, by 4 here, and by 4 here. And we get x squared minus 4x equals negative 76 divided by 4 is negative 19. And then we're going to go ahead and we're going to take our b term, right, whatever's in front of our x, and we're going to have it. So we have negative 4 over 2. We're going to square that, which means that we've got negative 2 squared, which is just 4. So we're going to go ahead and add 4 to both sides, right? This is going to give us our x minus 2, right? Square root of x squared and the square root of 4, x minus 2 squared equals negative 15. I'm going to go ahead and solve this just because I can tell right now that we're going to get an I solution, and I want to remind you how that works. We're going to take the square root of both sides, and I'm going to get x minus 2 equals the square root of negative 15. Well, this is the same as saying plus or minus I times the square root of 15. I can't break down that 15 anymore. It's just 3 times 5. Those are prime numbers. So our solutions to this are going to be x minus 2 equals I times the square root of 15, and x minus 2 equals negative I times the square root of 15. And the way we handle that is we're just adding 2 to both sides. We're not going to be able to break these down too much, right? This becomes plus 2. So this is x equals 2 plus I times the square root of 15. And when I add 2 here, I get, when I add 2 there, I get x equals 2 minus I radical 15. So you'll notice we get both solutions there, right? Definitely not pretty, but you get the idea, right? It's still solving for 2 different sets of problems. So that's all I'm going to give you for today. Work on the worksheet. Don't worry too much if you don't get it. We'll go over it some more next week. But make sure you get this Edpuzzle watched. So I guess if you got to me saying that, you've already watched it. There you go.